Okay, in this video, we're going to kind of pick up where we left off. Okay, so we're looking at still at function basics, but I'm looking at function notation now. So if we know something is a function, then we can use a special notation. So like y equals 2x plus 5, that would be a line that would look something like this. It would pass the vertical line test. It's clearly a function. And so if that's the case, then we use this function notation to indicate that. We can use this function notation. So this notation is a problem. You've got to really try to make sense of what it's saying and not hang on to your old associations that you've made for parentheses and that sort of thing. Okay? The biggest issue with this is that the parentheses make you think multiplication, and when I read this, I say f of x. And the word of you associate with multiplication. But f of x does not mean f times x, okay? So the way I want you to think about it is that what f really is here, the f, it is the name of the function, okay? It's the process of, in this case, multiplying by 2 and adding 5. It's that process, okay? So this notation is read f of x, but it does not mean f times x. Don't ever think that, okay? F of x is just the value of the function at x, okay? I should have added in there, f is not a variable. It's not something that can take on values. F is not a variable. It is a process. It is a set of steps, okay? All right. A really good way to make sense of the function notation is to think about a machine, almost like you're manufacturing a product. So you got this machine, okay? And you put something into the machine, and then the machine acts on it, and then something comes out the other side, okay? X is what goes into the machine. F of X is what comes out. What F is it's almost like the name of the machine. It's like the process that's acting on it. It's the squiggly line. It's what happens to X before it gets spit out on the other end. It's a really good way to think about it. So in our case, when you have f of x equals 2x plus 5, like we said, f is the multiplying by 2 and the adding 5. It's this process. It's not a variable, okay? All right, so the x is really your input. And then something happens to it. That's what f is. We might know what that is, okay? We might have the rule like we do here. F of x equals 2x plus 5, but we may not know exactly what the process is. It may be like inside the machine and we don't see what all's going on. But one number is going to be spit out at the other end, and this is your output. Okay, that's what f of x is. And the f of x and the y, they are interchangeable. Okay, they mean the same thing. It's just if it's a function, we're allowed to use that notation, and then I can ask questions and things in a different way than I normally would, okay? So for instance, if I ask you to find f of 2, find f of 2, you're being asked to find the y value that corresponds to an x of 2. Well, if you think about that, that's what we were doing when we were graphing. It's really this question. I've asked you that question before. Find the y that corresponds to an x of 2, and you would have just plugged the 2 in. You would have said 2 times 2 plus 5, and that would have given you 9. Okay? F of 2, that's what it means. Okay? So when you see f of 2 and you're being asked what that is, know that this is your x, and what you're looking for here is your y. Okay? And so the 2 is the x coordinate, the 9 is the y coordinate that matches up with it. Okay, so let's look at two different rules. One of them is the f of x equals 2x plus 5 that we've been working with. Let me raise this up a little bit. And the other is a slightly more complicated one. It's a quadratic function. So it has x squared minus 5x plus 1. And I just want you to learn to use the function notation. Okay, so for f of 3, 3 is your input. And so you would do 2 times 3 and add 5. 6 plus 5 is 11. F of negative 4 you would work out in a similar way. You would multiply your input by negative 4 and then add 5. And negative 8 plus 5, I'll go ahead and write that step, would give you a negative 3. Okay? All right, let's do that for g. Okay, g of 3. The g function's a little more complicated. It says to square your input, do 5 times your input and subtract that from what you had, and then add 1. And 3 squared is 9, so 9 minus 15 plus 1 is what I got. So let's see, that's 9 minus 15. That would be negative 6 plus 1. That would be negative 5. Right? I'm just checking myself. Yep. All right, now here's where people typically mess up. So watch this. Watch this one. Watch it here. The function rule says to square your input. So you don't want to write it without the parentheses like that. Okay, if you were to then use your calculator, it would give you negative 16 right there. But what it says up here is that the g function is this. Whatever your input is, you have to square that. So you should have parentheses. Let me do those in a different color. You should be thinking this. Okay, and then have minus 5, and then right there put your negative 4, and then have your plus 1. Okay, you see that? All right, so that's the negative 4 when it got squared. If you write it with parentheses, it means negative 4 times negative 4 like it's supposed to, and that would be 16. That would be plus 20. Plus 1, and you would wind up with 36, 37 for your final answer. So g of negative 4 is 37. These here at the end, these would be the answer to the question. Okay? All right, now when I ask you something like f of a, it feels like a trick question. Okay? These rules, the way they're stated, these equations, the way they're stated, use an x, but in reality it doesn't matter. They're just trying to say that. They're just trying to describe the process. They're trying to describe what happens to your input. So whatever your input is, you do 2 times your input and add 5. So this one just becomes 2a plus 5. You don't get a number, you get a new formula. Okay? And if I ask you to do f of x minus 1 is your input. You do 2 times x minus 1 and add 5. You have a little more work to do. You can distribute and then combine like terms to simplify your formula. But this is how you can create new functions out of old ones, this type of thing. It's like we just made a function h by taking the f function and inputting x minus 1, and then this is the new rule we got. Okay? All right, so that means g of a kind of works like f of a did. It's just replacing the x with an a. And then g of x minus 1 works like f did, except for there's a squared. So you have a little more work to do on this. Okay, so you got to take that x minus 1 and square it. Then minus 5 times the x minus 1, and then plus 1. And here's where if you're a little rusty on your algebra skills, you're likely to make a mistake. Okay, the x minus 1 squared is x minus 1 twice. All right, and then that negative 5 out in front has to get distributed at some point. Okay, so let's do the x minus 1 times itself. Wouldn't that be x squared minus 1x minus another 1x plus 1 when I FOIL that out? I'm going to go ahead and distribute. I'd get minus 5x plus 5. You see the negative times the negative, and then plus 1. Okay, now I'm just going to combine what I can. X squared, and then 1 minus 2, that'd be minus 7x, and then 1, 6 plus 7. And that would be my new formula. That's as far as it goes. You don't need to factor or do anything of that type. Okay, so that's kind of the intro to function notation. Okay, I also want in this video to let you see what I'm going to also do with function notation. I'm going to look at function notation not just with equations. People tend to do well with equations, but that doesn't always mean they have a good understanding of function notation. So I always like to look at function notation using different representations. So like sets of ordered pairs and tables. This is called a mapping, and this is a function that's being given to you in graph form. Okay, so let's try function notation with this. All right, now all of these are functions. I correctly use the notation at the right time. Okay, and I'm just asking you to understand how to find like f of 2 when you don't have an equation to plug into. Sometimes it throws people a little bit. Okay, but remember that what's in here is your input. These, the 2 and the negative 1, those would be your input. So if you have like f of 2 equals some number that you're looking for, this is your x value, and what you want is your y. So remember, ordered pairs are an x and a y. So these are the two you're probably looking at, but this wouldn't work. We need the 2 to be in the x spot. So f of 2 would have to equal negative 1. So when x is 2, the value of the function would be matched up with that would be negative 1. So do you see how what's in the parentheses is your input? It's your x. Okay, so let's do this one. So this one's asking us for f of negative 1. Okay, well, the negative 1 is the input, so it's the x. So when I'm looking at these ordered pairs that have negative 1s in them, the one I really need to focus on is this one, because it has the x value of negative 1, and I can see the y value would have to be 3. You can only have one answer here, only one answer possible if it's a function. If I'm using function notation, there can be only one output, only one y value for a given x. Each x has to have only one y. All right, now this question reverses the idea. See it, how it says the value of the function at x is 3, and your job is to find the x's. And remember, f of x is really just y. So that's really just y equals 3. Okay, that's really just y equals 3. And your job is to find the x's. So it's like this. You're looking for ordered pairs that have a y of 3. Okay, so let's go back. Here, this point had a 3 in it, this had a 3 in it, and this did. But that one, the 3 is in the x spot, so it doesn't come into play. But you see here, y equals 3 when x equals negative 1 or when x equals negative 2. Both of those, negative 1 and negative 2, would both be answers. Okay, so I want you to get used to function notation, but develop a really deep understanding of it. Okay, and so the f of 2, the 2 is your x or your input, and then the value you get for all of that, that's your y value. Okay, all right, so this is basically the same thing, it's just in a table rather than in a list. So for f of 2, you should look for 2 on the x side, and your answer would be what's on the y side. There's only one answer to these two questions. Okay, for f of negative 1, you shouldn't look at the negative 1 there, you should look at the negative 1 on the x side, and your answer is the y value matched up with it. Okay, but now this next question reverses the idea. Here we know the output is 2, and our job is to say what the input must have been. So for that one, okay, I need to look for 2 on the y side, and I can see x would have to be 0, and that's the only answer on that one. There's no other y's of 2. Okay, and then here I want the x or x's that make your output 0. So I look for 0 on the y side, and I see that happens only when x equals 1. Okay? All right, now look at this number 3. This actually is called a mapping. I could convert it to a table or a list of ordered pairs if I wanted. The arrow kind of tells you what gets matched up with what. See how you're starting with the -4 and it's associated with a 2? The ordered pair then -4, 2 is what you're being given. So you could make that swap, in your mind, or you could just use it as a mapping like that in that form, okay? So for this one, you want to think about your x's are here, your y's are there, and the function is what associates them, what puts the x with the y. You just don't know what the rule is, so you don't have the luxury of plugging that in. So for f of 2, 2 should be your input. It should be on the left side, and you're looking for what got matched up with it. Same thing here, f of -1. -1 should be an x value. You're looking for the y that's matched up with it. Okay. Now for the next two, we flipped it around. You're being given y equals 2, and you're asked to find the x that makes that happen. So you should look for the 2 on the y side and trace back and see that that would happen when x is -4. Okay, and then this one's interesting. This is still correct use of function notation, but these last two problems, okay, those all can have more than one answer. Sometimes they do. If I want the x's that make f of x equal to -1, -1 is my y. There it is. And I want the x's that match up with it. So that would be x equals 3 or x equals 5. Both an x of 3 and an x of 5 are paired up with a y of -1. So make sure you see that whole thing as your y. You're given your output and you're asked what the input must have been. Okay, one more thing in this video I want to do is look at another representation. Let's look at a graph. Okay, so we've looked at sets of ordered pairs and tables. Okay, this was a mapping, and now we're looking at a graph. All right, now with graphs, don't forget that these are really just sets of ordered pairs. See that red curve is really just a set of ordered pairs. Okay, so you could have put them in a list. You couldn't just you wouldn't be able to list all the ordered pairs, but you can imagine that. Okay. All right, so let me zoom this one in a little bit. Let me blow this up a little bit. All right, so when I'm asked for f of 3, 3 is my x, and I'm being asked what's the y matched up with that. Okay, so watch this. Let me get rid of the marks on here. Okay. All right, so x is 3. Remember, this is your x-axis here. This is your y-axis. And so I'm going to 3 on the x-axis, and I got to then see what point on the function has an x of 3. So when I'm at 3, I have to go up to hit the function. Do you see that? I have to go up to there to hit the function. So see, that's an ordered pair that's on the function that has an x of 3. And my job is just to look over and find out, well, what was the y associated with it? The y coordinate was 5. Okay. All right, and then sometimes you have to go up to hit your function. But see, when I try to do f of -1, here's -1. -1's your x. I'd have to drop down to hit the function. And then I could see what that value is. So when I have an x of -1, that's this spot. And what I see is that the y coordinate would be -3. Okay. All right, and then what happens if I give you y values? What happens if I want to know the x's that make f of x, this is really y, equal to -4? Okay, so if I ask that question, you should be looking for where are the y values -4, and that would be somewhere on this line. That's where y equals -4. Okay, so the f function, that's this. That's this graph. That's your f function. So you see that point right there is a point that has a y coordinate of -4. And you can look at that graph, can't you, and find out that the x would have to be 0. All right. Now the last one says find the x's that make f of x equal 0. So f of x equals 0. Okay, so that's the y equaling 0. That would happen anywhere you're here. All of those have a y equal to 0. Okay. So before, that was the only point that had a y of -4. Now I'm looking for where are the points that have a y of 0. What points of the function are on this line? Well, here's one, and here's one. See that? That point would be -2, 0. This point would be +2, 0. So your answer to that question would be x equaling -2 or 2. Okay. All right, so in this video, I was looking at, still looking at function notation, but just going on and looking at function notation, just still looking at the basics of functions, but focusing on function notation and going on and looking at function notation using different representations. People tend to do really good when they have like an equation to plug into, but sometimes folks don't really understand function notation, and so it doesn't make sense to them when they look at tables, graphs, or mappings. Okay? All right, we've got a little more to do with function notation in the next video, so I'm going to stop this one and then start the next one new.